Hello, Science Alliance. All right, we're doing about wind. I'm excited about this lesson. If you look up like how to make a tornado science activity online, everyone's doing tornadoes in a bottle. I think mine is better. I'm just going to say it, and we're going to make it in a minute. But first of all, I need to teach you about tornadoes. I asked you, I'm going to do that really annoying teacher thing of just not telling you the answer for ages. I've asked you, first of all, which horse on a carousel do you think is going the fastest? The ones on the outside, like where the people are that you can wave to, or the ones on the inside? Which one's going fastest? Or are they both going the same speed? The next question I'm going to ask you is, which one of these is a tornado? Are any of them a tornado? Are there any tornadoes in this picture? Again, this is what teachers do all the time. It's like we have to do it to get marks. You've got to show that people didn't know something and then you taught them a thing and then they get the question right. So are these tornadoes? You've got a dark cloud with a sort of looks like a mouse's tail sort of coming out of it. Number two, you've got an enormous, almost looks like a drill bit that is about to start drilling into a field, but it hasn't got there yet. Number three, it looks like an anteater's nose, I'm going to say, poking out of a cloud. And number four, you've got this massive sort of red cloud funnel that is touching the ground. Which one of those is a tornado, or any of them tornado? Have you decided? Quick! Is it all of them? Is it none of them? Is it just some of them? I'm not going to tell you that either. I'm going to tell you about tornadoes, and then you will be able to answer the question if you couldn't already. Right, a couple of weeks ago, we were learning about, I keep calling them air blobs. That's a better name. They are air masses. It's a proper scientific term. These are air masses, just huge masses of air that float around, and they generally always behave the same way on Earth. So you've got Arctic air masses that are cold, you've got tropical air masses that are hot, and we learned that when they meet each other, brilliant things happen. So a warm air front is when a warm air mass, not blob, and a cold air mass meet, and the warm air mass kind of wins and moves into the cold air mass. You remember this? And sort of goes up over it because warm air rises over cold air. And if the cold air mass wins, if the cold air moves into the warm air, then it sort of does the opposite. It scooches underneath it, right? So you've probably got a pen with you, or pencil. Can you just put a pen or a pencil or something on the table or the cushion or in front of you, wherever you are. If I said to you, can you push both ends of the pen to make it spin around, what would you do? What would you do? Come on, are you doing it? It's obvious, isn't it? You have to put, have you done it? Push both ends of the pen to make it spin round. You've got to push one side anti-clockwise and the other side clockwise, haven't you? You've got to push like opposite. If we're doing a proper physics, like one side you've got to push down and the other side you've got to push up. You knew that. Obviously you didn't push both in the same direction because it would not have spun. So forces that are in opposite directions make things spin. In a warm front or a cold front, occasionally what happens is you do get air travelling in one direction high up and travelling in another direction low down. And this causes something called wind shear, and it makes things turn. Do you see how we're getting to I keep calling tornadoes volcanoes. I can't stop doing it, so I apologise. It's going to happen today. Let me do one of my amazing, famous PowerPoint presentations to help your understanding. So you've got wind shear happening. Wind going one way, wind going the other way. That starts the air spinning, and then warm air rises, remember. So if some warm air happens to rise up through this, look what happens. Oh, now you understand. That warm air like knocks it sideways, and that's when you get a tornado. Well, sometimes. So tornadoes can happen for a variety of reasons. This is one of the reasons that they happen. So first you've just got a spinning cloud of air, and that is called a supercell. So this would be a storm, a supercell. Some supercells develop these things called funnel clouds, which is pictured here. I'll bring it down here because some of these photos are just great. And if a funnel cloud touches the ground, then it's a tornado. So this, look at that. Thank you so much, Justin Hobson. So that's a funnel cloud. It's not technically a tornado because it's not touching the ground. Actually, that almost looks like it's going to turn into a funnel cloud, doesn't it? It's only when it touches the ground that it's a tornado. So, come on. Are any of these tornadoes? 8 seconds. Picture 1, picture 2, picture 3, picture 4. Are any of them tornadoes? Just picture 4 is a tornado. Did you get that? Because it's touched the ground. So technically these ones are funnel clouds. Here's another beautiful photo. This is actually 8 photos taken one after another, and then this guy Jason stuck them all together. But isn't it great? So this shows you this is a funnel cloud, and then this is that funnel cloud just touching down, so becoming a tornado, and then you can see it kind of develops and develops. Right. Do you think it's time to actually make a tornado? I think it is. So get a pint glass of water. If you haven't got a pint glass, it's just got to be a tall, clear thing full of water so that you can see it happening. And you get a little bit of oil, not too much because I've only got super posh extra virgin olive oil, so I'm not going to use much. You don't even really need to cover the whole top of the glass. Just get a good blob on top. All right. Oh, it's the last lesson. I glug a bit more in. And then you need something, ideally like some little bits to sprinkle in. So you can't use powdered spice. Like if you just used cinnamon, I've done this a few times, then it just makes the water all cloudy, you can't see anything. But if you can get, I like herbs, I think will work quite nicely, like some little bits that you can sweep up into your volcano. For some reason, this 5 spice works really well. So I'm going to put this in. It looks like a powder, but it must be just bitty enough. There you go. So pint glass of water with a blob of olive oil on top and a sprinkle of spice or herbs on top. And then you just, with your spoon, obviously you push one way and you push the other way, don't you? That's what stirring is. It's like kind of creating shear, I suppose. Not quite, but it's close enough. So we're just going to do that. Yeah, and then I'll tell you a little bit more about tornadoes. I told you I'd do it. Right, let's get you a good view. I've got some sky from Lego Storytime. I'm going to put that in the background, just in case you're not doing it. But that's why I'm very proud of this activity, because everyone's probably got the stuff. Right, let's get you a good view, prop you up here. There we go. Here we go. A little bit more propping. Right. Oh, I should have said don't fill the glass to the top, because otherwise it spills. Yeah, sorry, didn't say that. You ready? You ready? It develops, it develops. Come on, look at that! Wow! That's a weird cluster of spice. Maybe we could pretend that was like Dorothy's house or something. Is that what happens? I can't remember. How good is that? I'm going to do it again. Apologies, bit self-indulgent. And do you reckon that looks like a funnel cloud? They were saying on Facebook yesterday. I'm a bit perplexed by this blob. Yeah, we could just say it's a, I don't know, a cow. Think of something you don't like. Not that I don't like cows. I'm trying to think of something I don't like. I'm struggling. It's aniseed. A big ball of aniseed has been swept up and carried away. Brilliant stuff. Look at that. Gross and cool. All right, that's enough of that. So, a little bit more about tornadoes. I dropped the bit of Lego that I used to prop up my camera phone. Wait, there we go. Tornadoes, there are some myths about tornadoes, mainly because of the film Twister, actually, because the films and cartoons that have tornadoes in them, you want them to be dramatic, right? Tornadoes don't have eyes. You sometimes talk about the eye of the storm. We'll talk about hurricanes in a second that do have eyes, but there's no, you can't stand in the center of a tornado and be safe in the calm air. Like they're just not big enough. They tend to be sort of fairly small. The widest what is it with the words volcano and tornado? They're just the widest tornado that has ever been recorded was 2.6 miles wide. So obviously ridiculously wide and very dangerous and caused a lot of damage, but that's the biggest one that has ever been recorded. So they don't get bigger than that generally. They don't last that long. Like sometimes they might last for a few hours, but it's much more likely that they last for about 10 or 15 minutes. They could just appear like ours did and then disappear again. They do happen in the UK, because obviously we get, most of you in the UK with me, you do get warm fronts and cold fronts, so you can get wind shear in the UK, but they don't tend to be powerful enough to cause any damage. The main place that tornadoes happen, you look at our air masses map again, they tend to happen here. In fact, this part of the world, like sort of Texas, south of North America, if you know what I mean. This is called Hurricane Alley, and it's because you get cold air masses and warm air masses meeting there very frequently. So that's where the tornadoes happen. Right. I think I've told you enough that you can do this question with me. So on Facebook for the last couple of lessons, I've been asking people, how was what we just did a good model of a tornado, and how is it not a good model? When I say model, I mean the physics, like science meaning of model. A model in science is just, does it help you understand something well? So like a globe is a good model of Earth because it's a sphere. It's like a ball shape, and Earth is a ball shape. A globe is a good model because it spins around. So it helps you understand that Earth spins around. A globe is not a good model of Earth because your globe is probably hollow and Earth is not hollow. So it doesn't mean like a model on a shelf. It means basically, why was this like a tornado and why was it not like a tornado? So I've got loads of answers that I can give you that people on Facebook gave. But I'll give you, I might actually properly time it in my head. I'll give you 1 minute. Can you write down or shout out as many things that you can think of for why our tornado in a glass was a good way of describing how a tornado works? Why was it like a tornado? And how did the model fall down? How was it different to a real tornado? Just going to do it again. Oh, so good. I've failed to count in my head. I'm going to say you've got 46 seconds now. You could be really obvious as well as you could think quite deeply about it. And then I'll show you what everyone on Facebook wrote. Should I put up one of the answers that they gave me on Facebook to give you an idea? It spun around. That is how it was similar to a tornado. If you are on Facebook, there is a post on my Facebook page right now saying, please comment here if you're watching live. So you can always go over there if you're absolutely burning to tell me. And then there's no comments on YouTube, but you can write them there and I'll go there at the end. People were thinking about water and air. People were thinking about temperatures, size, how long it lasted. Okay, right, I'm going to be quiet. I'm going to be quiet for 20 more seconds and then I'll show you all the answers. All right then, here's what they said. It spun around, and like a tornado does. It picked things up. Someone said yesterday, like it picks up the bits of spice or the herbs, so that's a good model, because a tornado does do that. A tornado could actually last that long. Definitely a tornado could just appear and disappear in a few seconds, so that was why it was a good model. It involved a funnel cloud. Did you get that? So, I mean, actually, a lot of people were saying it was a bad model because it didn't touch down. You might be able to get one that touches down, but yeah, mine doesn't quite touch down, but I suppose it was a good model for a funnel cloud. And I wrote it happened in the UK as well, because I live in the UK and this model is also happening in the UK. Why was it different to a real tornado? Yeah, it didn't touch down, so technically our tornado is not a tornado at all, I suppose. Tornadoes made of air, not water. You can get... Couldn't really find any good photos of them, but you can get something called a water spout, which is a tornado that has formed and then moved over water and kind of sucked all the water up. But it's not actually made of water, like the water isn't the thing that starts to spin, if you know what I mean. But yeah, look it up, water spout, tornado, moves over water and all the water goes. It's very cool. But yeah, tornadoes are made of air, and our tornado is made of water. The funnel cloud came after, not before, people were saying. So if you manage to touch the bottom of the glass, then you get a tornado, and then later on, as it's starting to fade, you get a funnel cloud. Whereas obviously in real life, you get the funnel cloud and then it touches down. It's a lot smaller than a real tornado, and there were no it's gone, but there were no differences in temperature involved, people were saying. So a real tornado, quite often it's caused by differences in like pressure or temperature. Right, should we move on to hurricanes? First question, and then we are going to get to the carousel thing. What's the difference between a hurricane, a typhoon, and a cyclone? This is not a very good teacher question. It wouldn't get me any marks in my teacher exam, because it's just, if you know, you know, and if you don't know, it's not very interesting. The answer is they're all exactly the same. It's just their names that are different. So here's a picture diagram of where all the tornadoes, typhoon, cyclones, they're all the same thing, happen on the planet. If it's up around America, then they call it a hurricane there. If it's where like Indonesia and Japan are, then they tend to call them typhoons. And if it's sort of around Australia, then it's called a tropical cyclone. The actual technical name for them that scientists use is tropical cyclone. So a hurricane is a tropical cyclone, right? And a typhoon is a tropical cyclone. And obviously a tropical cyclone is a tropical cyclone. Is that okay? It's like, well, yeah, there's no need to come up with an example. It's just tropical cyclones. In some parts of the world, they call them hurricanes, and in some parts of the world, they call them typhoons. If you're like me and you speak English as your first language, you've probably heard of hurricanes more. You probably say hurricane because we get our news from America, because they also speak English, so we hear the word hurricane more. But strictly speaking, we should be calling them tropical cyclones. Right, have a look at this map. See if you can... I was impressed, actually. People were getting this on Facebook. I didn't think that you would get it. Have a look on this map. Look at where the arrows start. So this is the path that hurricanes take. So where the arrow starts is sort of where the hurricane forms, and then this is where they travel to. But just looking at where the arrows start, do you notice anything? There's two things that you could notice about where hurricanes start. So well done if you are saying that they start in the sea. Yeah, they do, don't they? They all start in the ocean. There's no arrow that starts on the land. And there's another thing, if you just look at where they begin, they all start kind of in the middle of the planet, or like certainly around the middle of the planet. All right, I deleted one from here because it's incredibly rare. But generally speaking, all these arrows fall in this kind of belt. So, it's finally time to talk about that carousel question. If you have got a pen, then can you just hold the end of the pen and like just pinch the end of it and sort of spin it around like that? I mean, I suppose if you're clever, you could spin it around like that. Imagine that there are little people sitting on your pen, and think about how far they are travelling right now. So a person sitting right on the end of your pen would be travelling really quite a long way, right? I'm just marking it on the board. So if that's the very centre, a person sitting right on the end of your pen would be making that journey every time you spun the pen around. Whereas a person sitting sort of quite close to the centre of the pen, they would be making a journey of a lot less distance, right? And if a person was sitting where your finger is on the pen, they would just be spinning around. So this is a weird thing about carousels, is that obviously all the horses on the carousel set off at the same time, and they all get back to the same place at the same time, right? They all stay in line with each other, don't they? But the one on the end is going a lot further than the one near the middle. So the one on the end, it's travelling a further distance in the same amount of time. So it's got to travel faster. It seems weird, right? But yeah, the one on the outside travels a lot faster. The one on the inside, hardly travelling at all, just spinning around. This is quite a good model for Earth. If you imagine that we're looking down on the Earth now, so imagine this is the, let's say it's the North Pole. If an air travels with Earth, right? This is why Earth is spinning right now, but you can't tell because everything around you is spinning. Your house and the trees, even the clouds, are all spinning at the same speed as Earth. So anything in the middle of the Earth, we call it the equator, right? Anything kind of right on the outside is spinning really fast. I think it's 1,600 miles per hour. I might have made that up. If you're standing at the North Pole, then everything's like hardly moving at all. It's just spinning. So this is what air does. Air at the equator is spinning really, really, really fast. It's called the Coriolis effect, if you've ever heard of this. It's what people think affects toilet flushing, but it doesn't. Air on the very outside of the Earth, the equator, is spinning really, really, really fast. And then if and when that air travels up to the North Pole or down to the South Pole, it doesn't really slow down. So you get air that's travelling really fast, but it's travelling over land that isn't turning that fast. And this results in this weird curling effect. So last week, or maybe the week before, we learned how the Earth circulates around Earth. Kind of looks like Earth has got beautiful curly hair, right? So these are called cells, and air just kind of, warm air goes up and then cold air comes down. And obviously you can't see it in this picture, but the air's going like across the planet as well. So we learned, yeah, I've just written that down on the PowerPoint for you. So there's certain winds that always blow in the same direction, right? If you live here, then you're always going to be experiencing wind that travels in that direction. And we learned that these are called the prevailing winds. I mentioned that really quickly. And here is a picture of the prevailing winds. But because of this Coriolis effect, the air spinning really fast that kind of goes up and down, the prevailing winds are kind of curling. Can you see? Maybe I should move you down here. And this is why tropical cyclones always go in a clockwise direction above the equator, and they always go in an anti-clockwise direction below the equator. That was quite a lot. I'm not expecting you to remember all that, but basically there's always wind that travels in a certain direction and it always curls because it's air that's travelling around the planet, but yeah, it gets sort of thrown around by this Coriolis effect. Yeah, so that's it. That's why they always go one direction in one side, and that's why also none of those arrows really started right on the equator. Because the air there, right on the equator, is travelling at the same speed as Earth. So you don't get that curly effect. Right, again, not actually going to test you on that. Don't expect you to remember that. Just interesting. Okay, let's look at some cool photos before we go to the last question sheet. So hurricanes are massive. They are thousands of miles across. They involve vast amounts of energy. They can only form over water. What happens is, again, I feel like I'm talking a lot. I'll be very quick because it's interesting, but yeah, it's not something that I would test you on. They happen where water has to be warm, right? You have to have like maybe the first 46 meters of ocean have to be almost as warm as your bath, like 26, 28 degrees. Wind blows over the warm water and the warm water evaporates into the air. And then when it cools down, it forms clouds. That's the easy bit. Warm water particles go into the air, form massive storm clouds, like tropical storms they're called. The bit that goes into IGCSE physics is because these water particles have got energy, when they cool down, they lose energy, and that energy's got to go somewhere, so it heats the air. I'll send you some links on my Facebook group, but basically, water particles, a lot of energy, cool down, form massive storm clouds, heat the air rises, and you get this enormous amount of turning clouds. So this is a tropical storm, and sometimes a tropical storm turns into a hurricane. Hurricanes do have eyes, and their eyes can be like 3-5 miles across. This is a photo taken by an actual human that was on a spaceship orbiting Earth because humans are amazing. Imagine actually looking at that and just taking a picture of it with your phone. So this is the eye of the hurricane. The air inside the eye of a hurricane is calm. In fact, people go in there to study them. An interview with someone said that it was actually, they felt a lot safer in their little plane inside the hurricane than they did on the outside, because that's where all the destruction happens. So this is inside the eye. This is someone from the American Air Force. This is the hurricane wall. Apparently that's the most dangerous bit, like the eye wall, because that's where the winds are the fastest. Yeah, I mean, what? So tropical storms sometimes turn into hurricanes, not always, and they're thousands of miles across, and they can't exist on land because they need warm water particles. Warm water particles make air, make clouds, and so they're kind of driven by warm water. So we don't get them in the UK because our water is too cold, and you don't ever get them on land. But when they move from water onto land, as they die, they unleash huge amount of water that they've been carrying. It's called a storm surge, so they can cause a huge amount of destruction. Right. That was so much information. Have a look at this sheet. Maybe I should tell you, I think there are 4 facts on this sheet, and the other facts are, in fact, not facts. Get it? Have a look at this. You do some work. I've been chatting for ages. Which facts are correct? And the most important thing, can you explain why the wrong ones are wrong? So like I say, 4 facts here for you. And why are the things that are wrong? Wrong. Right. Hurricanes and tornadoes only form over the ocean. Is that right or wrong? The air is calm in the eye of a tropical cyclone. Correct or a lie? Hurricanes can last for weeks. True or false? Didn't actually tell you that one, did I? Tornadoes can be thousands of miles wide. Is that true or false? All typhoons are tropical storms. All tornadoes touch Earth's surface. The UK has hurricanes, but they don't cause much damage. The air is calm in the eye of a tornado. And all tropical storms are hurricanes. So 4 of those things are true. The most important thing really is for you to explain why the things that are not true are wrong. I guess you kind of got some clues here, because that's a little picture of a tornado, and that's a picture of a hurricane. How are you doing? Shall I go through the answer? Okay, I'll tell you which ones are right. The air is calm in the eye of a tropical cyclone. That is correct. You could drive a plane into it, although don't do that without training. All typhoons are tropical storms. Yeah, they are. All typhoons are tropical storms. All tropical storms don't turn into hurricanes, typhoons, and cyclones. But if it is a cyclone or a hurricane or a typhoon, then it is a tropical storm. That was quite hard. Hurricanes can last weeks. Yes, they can. They can last up to a month. And all tornadoes do touch Earth's surface, or they would not be a tornado, they would be a funnel cloud. Well done if you got those. I'll pop you back up here and just wave the screen in your face for a bit. So hurricanes and tornadoes only form over the ocean. That's not true, because it is true of hurricanes, but it's not true of tornadoes. Tornadoes are caused by lots of things, but just wind shear. So you can get tornadoes inland. Tornadoes can be thousands of miles wide. No, the widest tornado was like 2.6 miles wide. Tornadoes are sort of fairly small. The air is calm in the eye of a tornado. No, tornadoes do not have eyes. That's apart from in the films. It's only hurricanes that have eyes. All tropical storms are hurricanes? Yeah, no. Tropical storms can turn into hurricanes, but they don't always. And the UK has hurricanes, but they don't cause much damage. Some people were arguing about this with me on Facebook. I know, right? How dare they criticise, not recognise my authority. The UK doesn't have hurricanes because hurricanes only happen where the water is warm. But we do get like the dregs of America's hurricanes because of the prevailing winds. So when hurricanes die, we do still feel the effects. Sometimes the very strong winds can travel over the ocean and get to the UK. So maybe the news uses the word hurricane to like make it sound exciting and dramatic. But technically it's not a hurricane. Okay, right. That's the end of the lesson. Thank you very much for coming. I'm going to go to my Facebook page and see if anyone has left me any comments. If you enjoyed this lesson, you can pay me for my job. You can, if you want to. You don't have to. But someone has to, or I'd have to work in a school. So if you are supporting me, you hopefully will have received Theatre of Science magazine. They should have all been posted by now, like if you've been supporting me for a while. If you signed up in the last couple of weeks, I'm still kind of frantically ordering more stamps and packing. But yeah, everyone who sends me £5 a month receives Theatre of Science magazine whenever I've written it. So sometimes it's more frequent than others, like every few months. Now is a very good time to sign up. So if you sign up to sort of contribute to my wages with £5 a month, you usually get a past issue of Theatre Science magazine. So you would get mould, in this case, with a free compostable plastic bag. And then you get the next magazine when it's out. But I'm saying it's like buy one, get one free. I'm going to finish that deal today. But if you sign up now, I'll send you the past magazine welcome pack, and you'll also get the latest magazine, which is on weeds. I hope that you've started to receive it, my loyal supporters. This one took ages. It was very enjoyable to write. I basically wanted you to be able to look down at grass and know that it's not just grass, and be able to appreciate just how amazing all these little plants are that we take for granted. So there's a big sort of, what do you call it? I love these things where you find a flower that looks a bit like a dandelion, and then you answer the questions and it tells you what it actually is. There's a beautiful comic that my husband illustrates for me about the first woman to travel around the world. There's like one of those little fortune tellers with real fortunes from ye olden times. There's a game which isn't Dobble because for copyright reasons that would be bad, but you can cut out these cards and like play a game, and it helps you to identify weeds, very common weeds. All right, I'm going to go to my Facebook page. Whoa, there's loads of comments. There's 36 comments. Right, if you haven't commented, you might want to leave. Because I'm now just going to be chatting on to people. If you like my Lego Storytime shows, there's one of those at 10:30 coming up, which is all about inventions of the medieval Islamic world. Is this lesson 3? Yes, it is. Oh, thanks, Bella. Oh, Laurie and Flynn are here. Hello, Laurie and Flynn. Hello. Oh, hello, Naomi and Josie. Yeah, I knew you were watching. Oh, you got the magazines in the post. They are really good. Oh, thank you. That really means a lot. I'll tell my husband. Oh, Bella, excellent. You got your magazine. That's good. Judah and Eden say hello. They are watching their sister open birthday presents, but love that you're talking about wind. Ah, Judah and Eden say hello to your sister and happy birthday. It's exciting. Oh, Luna, that's nice. You enjoyed that. Naomi and Josie ask if a tornado can travel across the sea. Ah, that's a good question. Can a tornado travel across the sea? Well, yeah, I guess it could for a bit, but not for long because they don't last very long. But yeah, like a water spout could definitely like move around. In fact, we should all be looking that up on YouTube. Oh, hello, Zach and Henry are here. They might not still be here. We've been chatting for a long time. Zach and Henry have been members of the Science Alliance for ages, like literally years. No way! T's got a Wary badge on! Yeah! Oh, amazing! Oh, hello, Bailey and Tate. Hello, Tate. I can't believe you've still got that Wary badge. That's awesome. Oh, Riley and Hallie are here. And I can see their volcano. Yeah, a tornado. In fact, it's a funnel cloud, isn't it? Oh, yeah, that's a good one. Oh, Robin and Hissy, hello. No way. So Robin's got this pet snake that always comes. It's a toy snake. But now Steve the beluga whale has also come in. Steve, welcome. I hope you enjoyed today's lesson. Hello, Freya and Orla and Isabel. God, sorry, if you commented like 40 minutes ago, it's taken a long time for me to say your names, hasn't it? And Edwin and Solomon and Jeremiah. Hello. Yeah, I know, right? Tornadoes was a good shout for a lesson. Hello, Ava and Will. Or Arthur and Will. I still don't know, Arthur. I'm just going to say a different thing each time. You put your finger in your tornado, but it didn't reach the bottom, so it was a funnel cloud. All right. Good model has reacted like a tornado. Oh, yeah. All right, Jack. Hello, Emily and Christina. Hello. You're going to try different glasses. Oh, that's a good idea. And different particles. Yeah, that's a great idea. That's like a whole day. Excellent. Hello, Noel and Eleanor. Ours was too small. Oh, fair enough. All right, Bella. Oh, I love looking at the photos of you. Tiger, the black belt. Congratulations, dudes. Nice. And Bird. Hello. Bird, I hope like Tiger's not pressing on you. Oh, that's great. Well done. A black belt. Where do you go from there? Is that it? You just have to like make movies now and teach other people. Kian says hello and it's windy. I know. This was accidentally a really good time for this lesson. Hello, Abba and Arthur. Oh yeah, there's Zach and Henry. Oh, Imogen and Ophelia. Hello. Oh, the whole core Science Alliance crew is here. Hello, Stanley. I know that Stanley's been using this quiz to find out different dandelions. Stanley, do you know When I first started it, I was like, I can think of about 3 flowers that look like dandelions. This will be easy. And then it just got so complicated. Oh, and Sky and Evie are here. Hello. I thought you would be. Oh, and Tor. Hello, Tor. And Chloe. Hello. Hey, hello. It is Suki and Arza and Eunice and Salah and Musa. Hiya. Would hot oil and cold water make it run for longer? Oh, I don't know. But please do that. I mean, maybe you should do hot water and cold oil because hot oil is dangerous. Hot water and cold oil. I didn't think about that. Please try. Not as good. Not good as underwater. Yes, correct. Thank you, Second Henry. All right, you lot. Well, I'd better go and set up Lego Storytime again because it's all over the place. I'll maybe just refresh and see if anyone... So I know sometimes people come to the comments when I do this bit and then I just log off and I haven't read your new comments and that might be quite annoying. Yeah, look, there's loads of new comments now. So I'll just read these as well. I don't know why I feel bad about this. Like, oh, this is boring. You can just go, can't you? No one can see you. It's not a classroom. Like you're not like making a rude noise of a door slamming behind you or anything. Oh, hello. Also love the Weeds Mag. My 7-year-old loves it. Oh, thank you. Oh, that's great. Oh, brilliant. Oh, Riley. Oh, you've got a Jurassic Park hoodie. Oh, I'm so jealous. Oh, that's really good. You can't ever really see what I'm wearing on these. I feel like I need jumpers with like, maybe I need to get some Jurassic Park patches to put on my shoulders. Oh, yeah, I'm very impressed. Laurie and Flynn are here. Loving the tornadoes, says Kerry. All right, I think that's everybody, is it? Yeah. Oh, no, hold the phone. Poppy's been drawing pictures. Poppy, that is awesome. I released 8 baby molly fish with their parents. What? Not into the tornado, I hope. I don't even know what a molly fish is. And you got 8 of them. Oh, hello, Reese. Hello. Yeah, that is a good picture. Look at that. 1, 2, 3. Oh, amazing. Look, I'm just going to show this. There you go. Isn't that awesome? I never get to show people's work on here. Funnel cloud, touchdown, fully developed tornado. Love it. Wow, you did all that just while I was chatting. Okay, right, I will go because I've got to start up Lego Storytime. But yeah, I'll see you all very soon. If not next week, there is a thing now on my Facebook page telling you what lessons are coming up. So next week it's precipitation, like snow and rain and stuff. The week after that, it's how we actually predict the weather. It involves a lot of balloons. Oh no, it's clouds, and then how we predict the weather, and then climate, like deserts and the Arctic, and then finally climate change, and then a week off, and then we start the lessons on flight. Okay, now I'm gonna go.